Okay, so let me just quickly start. Hi, I'm gonna introduce myself in a second, but first, just wanted to let you know, who has maybe seen my other talk about automating stuff with Python and blueprints? Anyone? Okay, so part of this content is gonna be the same. I extended on this content, but if you have seen it already and you want to maybe, just go see another talk, I'm not gonna be offended. Feel free to. But there is a part of I want to focus on entirely different things this time. So let's try to do this. Hold on. Okay, so I don't see anything here. Do you see anything? No, okay. Anyways, I'm Krzysztof, and I'm evangelist at Epic, which means basically feel free to approach me if you have any questions or matters to talk to us about. So feel free to reach out. This is my email. This is my Twitter. Those will be also at the end of presentation. A few things so a lot of basis of what I'm talking about here I also covered in a live stream, so you can take a look at that. It's 2.5 hours long thing where I go through a lot of the things I'm gonna show you briefly at the beginning. And since this is Game Industry Conference and I was able to set the level of the talk to intermediate, I'm gonna skip some stuff that is obvious for me. So, if you're looking for more details, it should be there. The more grounds up things, I'm gonna focus more on the ideas of how to approach it rather than the implementation itself, although I'm gonna show some of this stuff too. So let's quickly do a intro about basically creating tools and custom tools. This is not a custom tool as such. I mean, geometry tools maybe in Unreal Engine 5. This is, though, a tool, definitely. And such tools, I would say this is very much possible to do with Python or blueprints. So, something on the complexity level of the editor tool is kind of possible to achieve. But let's quickly talk about the whole idea in general. So why the tools are at all important to us? So the engine has to be done in a very generic way. We have to serve all the purposes for all the developers. And we cannot take care of some very specific things you may need to put into your process to speed things up for your project, because maybe you use this very specific workflow where textures are being converted into something meaningful to you in a very specific way. I know I'm quite vague now, but there's a lot of specific use cases that you may have, and the tools in engine cannot support all of that, and yet you may need to speed your workflows up a little. So you can make custom tools, and those custom tools are designed they're not designed, but are meant to serve yourselves, not the players, just your team, basically. So this is one of the important things. And this way you're able to add new functionalities to the engine or operate on assets or data in a way that engine doesn't usually operate, and this way you're able to streamline a lot of processes along the way. So let's quickly go through some of those misconceptions that people used to have since Unreal Engine 4, because I remember 4 years ago, I guess, 2018, I gave a talk about creating tools in Unreal, on this conference, and it was completely C++ heavy. There was no way to actually speed things up or make them easier. And most of the tools, the simplest ones, for example, adding one button to the editor, they required creating 4 different classes, defining the style, creating actions for those, actions which then can be translated into execution of some function, and there was a lot of this boilerplate code that you had to write and create. It's still there. If you want to create a pro tool in Unreal using C++, you usually still have to write this boilerplate code, but not anymore. In the case where you don't need to make a super huge complex thing that you want to, for whatever reason, bring to C++, right? So those tools also are valid still, But we're talking here about things that are accessible to everyone without any C++ knowledge, without any like programming knowledge itself. Basically, currently, I'm gonna try to prove to you that the tools created in Python and blueprints themselves can bring you basically most of the advantages that that you can get from creating that you could get from C++ only in the past. So very quickly again, Callin Editor, you know that, I guess. I mean, like this is just a checkbox. Hold on, in here. Can we make it brighter? No, I guess so. I guess not. maybe the room darker or whatever. Anyways, if you have an event in Unreal, you can select a Callin Editor checkbox, and then it will be available to you as a button. One important thing is like it's being, if you select a lot of instances of the same actor and you click this button, it will be called like per instance, it would be another execution of this function. So like for example, if you randomize something, a different random material will be selected for each of the selected things. So like just one thing that may be good to note. We have things like geometry tools, which allow you to, for example, create and modify those shapes in a scriptable manner, in a programmatic way. And I just kind of got inspired by Lyra and did entirely different approach to that, but using just blueprints in Python, actually just blueprints and just the Callin Editor function, and creating a few structures just to like be able to keep those data and move them across instances. I created a thing that I called like, I guess, mesh generator. And mesh generator can generate a sphere or a box with a hole in it. I mean, like, which is empty, basically. So with wall thickness and stuff like that. And the data I'm using to generate this stuff, I'm just keeping as a property in this blueprint. I'm hitting a button, which is just a Callin Editor button, to be able to, and I'm able to save this stuff into my content browser, into the asset, replace the dynamic mesh with a static baked instance of this with just one click of a button, and then get back to editing by clicking Make Editable. And this runtime mesh actor is just a static mesh actor based blueprint, which has this button that is like that is set to be Callin Editor function. And using the data that I transfer from one actor to the other, I can just create a mesh generator again from it, and then bake it, and then go both ways very quickly. What this gives you, I mean, like the mesh scripting, it's called geometry scripting, sorry. Geometry scripting is, so dynamic meshes are super heavy, so you don't want them at runtime. That's why you can very easily like bring this stuff to bake it, basically, with blueprints only. Again, another idea, like you can have multiple properties. I just called a category of those properties snap. And like if you just, like in this case, I'm snapping things to walls based on basically the direction that I select with this vector. I mean, so this way you can just create, for example, something like this. If you have an uneven surface, not something easy to work with, you can, like, for example, just distribute those things using just raycasting towards walls randomly, and you can have kind of semi-even random distribution of actors around the uneven surface. Quickly about blueprint utilities. I'm not going to focus too much on those because I'm more into Python now, so sorry about that. But this is mostly the same stuff. Just sometimes Python may be a little bit easier to write quickly if you want to manage it. Like creating tools is usually messy because you just experiment and fiddle with things. So, but let's take a look at what this editor scripting in general gives you, because editor utility blueprints is the moment where you get access to editor functionality editor functionalities in blueprints. And there are a few types that I think are like major, I would say, or like most important. Some of those, I'm not even sure what they're meant to do, except for that, like they are basically, so editor utilities is something is this class, but it also has editor functions in it, basically. So if you have like editor utility actor component, you can create an actor component that will be able to access editor functionalities. So basically, this is how it works. But there are some things good to know. So editor utility actor, as you probably might have guessed it's a thing you can put on the scene, but it's also, it can access editor functionalities. It's not gonna be cooked with your game, because in runtime you cannot use editor scripting, which makes sense because there is no editor code in your packaged shipped game, right? Okay, so editor utility object is basically just a U object, but it can access stuff from editor utilities, right? The same goes for editor utility widget. This is just a widget that can access editor functionalities. And then a few other things like asset/actor action utility means basically there is asset action utility and actor those are so difficult to pronounce. Actor action utility. And those have a very special use. So in this case, you can see in here example of that. For example, our asset utility will allow you to right-click on assets, and if those assets match the class that you selected for this utility, you will have an option to add like a menu entry, which will basically call a function for you. So this goes the same for actors, and this means basically if you select things on the scene, right-click it, you're able to access some actions that you defined inside of this class. And those are just functions. And one important thing to know and to remember about Blueprint utilities, take a look here and you can see that I'm not using the Blueprint submenu, I'm using Editor Utilities submenu, and this is super important because this is like a different type of asset in general. If you create a blueprint of type Editor Utility, like asset action utility or something, it won't work the same way. Or like editor utility widget, if you create it just from the regular widget blueprint, you will be able to create it, but it won't work the same way, so you won't be able to use those functionalities, and those are super difficult to track down. So just make sure you do it properly, you know. Right-click and editor utilities. I'm really stressing this out because I've spent hours not being able to find out. So. A few things. Those are the things that you can access directly, and those are the subsystems that you can access, and then those subsystems have also other stuff. You know, I mean, like those are looping, so don't be fooled. It's not just constantly going down, but it's like 30 of those, hundreds of those, and then each of them has tens at least of other options available to you, so you can basically control anything. Let me say that. Okay, so this is just a slide. By the way, the whole content here is available to you later. I mean, like there's a link at the end of this presentation, so you'll be able to download this. This is mostly, like the presentation is mostly for your reference. That's why I'm not going too much into detail with those. But a few things that I noticed that I really like. First of all, I mean, like, yeah, you can control the whole source control stuff from blueprints, right? So if you want to process a lot of data at some point, but you're using source control, you don't have to, when you set up the process, you don't have to like first, okay, sit down, check out all the files I'm gonna process, and then, you know, run the process, go home, get it back. You can just have it all done automatically for you together with a commit. So you can just hit process and go home and then get back tomorrow, even like, you know, maybe don't check at home if it went through. I mean, like, because health, you know, work-life balance, but, you know. This way you can be hands-off with that. Okay, so for example, things like you can create a new blank map, and you can also decide if you want to save an existing map. And if you don't know, but you want to ask the user, show them a message dialog, and then decide based on their answer, you know? So you can get a lot of those things done. A few nice things also filter by class. So if you have an array of actors that are selected by user, for example, you can filter them by static mesh actor and get them done. I mean, like usually, I don't think this is available outside of editor, maybe, but it was but I'm not sure if this is super well optimized. The thing about tools is that it's you who will be using it, right? I mean, you don't have to take care of the end user. You don't have to take care of so many edge cases. You take care of your edge cases of your user, right? Of your team, and of course, best to optimize stuff. But if you can write a tool quicker, maybe do it. Why not? And then have it run 20 minutes longer, during your time when you're at home and you don't care anyways. Okay, let's take a look at the utility widgets, and this is a very, very important part because those give you a few cool new things. One thing to know is basically that, as I said, it's you create them for yourself. You don't have to take care of them, but you can make them fancy if you want. You have the whole UMG stuff at your hand. If you know UI, why not make it colorful? I don't know, do it. But you don't have to care about it. The same, yeah, sorry, just one thing I had at the tip of my tongue. What they allow you to do, though, with all those things in mind, you can actually access some stuff like details view or property view. And you can see I'm showing here, that how I set this up, and why I'm using pre-construct is basically because I want to see the widget also in the design view. So you can see as well here, if I have a proper object selected for the property view, I can see in the design view, I can see a preview of that. If I didn't do this, I mean, it would be also fine. Just I wouldn't be able to see it. So, and let's see, I'm fine. Okay. Why I'm not using pre-construct everywhere? I mean, so basically both construct and pre-construct are meant for not really critical code. So, so this is more for cosmetic stuff. So of course, this is all connected to UI, so we're using it. It's not running at games runtime. But that's why I kind of restrain myself from using pre-construct for everything, because it's makes more sense. I'm not sure. So I played it safe. And in property view, you can not only do you supply an object that it matters for you, but you also select a single property, and it will spawn a widget for your user. And the funniest, the nicest, or I guess nicest thing in general, is that if you plugged it into a specific property, you won't have to, I don't know, convert the values to the type that is that the property is. For example, if you want to have a Boolean value, you will have a checkbox, and this checkbox will be already, the value of the checkbox will be the same as the value of this variable. The same goes for the text, the same goes for floating points, the same goes for class type, right? So you can basically do a lot of stuff. This is just how you can do it in two different ways. In case you don't know, you can create an event to not have those long cables, but this is this is an example of how you can react to changes to those. So if you, there is this I guess this is also the same in C++, on property changed, right? You get the name of the property and you can react to the specific change of this property if you wanted to watch it for whatever reason, and then, set something based on that. 2 words about transactions. I hope to show you an example of how to work with that a bit later. So in Python, but for example in blueprints, transactions are the undo redo buffer. The only important part to know about is that you do most stuff before you do changes, not after, and this is why. So first of all, you define a transaction, and this transaction basically you give it context. Context can be whatever it's makes sense to you. It's not gonna be visible to the user. Description is gonna be visible to the user, and you just began a transaction. This from this moment you can cancel it based on this ID, or you can end it, right? If it went fine. And while doing that, you can use snapshot or transact object per object that you process. So transact object from snapshot differs just in a way that transact object marks it as modified. So if you are modifying an asset, it will also mark it as to save, so that you can, whenever you hit save all, it will be also available there. I mean, like it will be, the engine will be aware that it has been modified, basically. And you do this before you modify your asset, actor, or whatever you're working on. So this is because this is the moment where it snapshots the state of the thing before you want to go and modify it so that you can later get back to this state that you took a snapshot of, right? So this is the only thing to know. There is a macro. Yeah, snapshot object, not that useful, I would say. Anyways, so begin transaction, you can see in here, we go to some loop. Don't look at what it does, it doesn't matter. And then we do transact object at the very beginning of this loop, and I'm applying this because I'm processing each element of this loop, of this array, of the selection, basically. I'm processing each selected actor, so I just transact them one by one. And then when I'm done, I do end transaction, and that's it. You know, and this way I can like go Control Z and revert things. So let's now try to move to this stuff. All this you'll also get. So very quickly. I have a button here. I'm gonna get back to the button creation for a short second in a moment. And just to quickly show you an example of a tool. And the general idea for this tool was that I wanted to be able to create one tool and then have different ways of processing things with the tool. And how I did it, how I achieved it, was basically that in here I select a class of the processor, I would say. So, for example, my circle distribution or like Fibonacci sphere distribution. And this way, if I save my selection, for example, I can now set some points, like this will be my center of whatever I want to do. From the center to, like, for example, this actor, I can move it around here, and I can set size, and to visualize this, I can go live preview. So you can see that, I mean, like, basically, I'm doing some basic maths, and I'm just using it in a way that makes sense for me, right? So I just take the position of this actor, position of this actor, subtract them. I have a radius. This actor is my center, so I have the position. So this is my vector that I'm using for that. Basic stuff. And when I hit execute, those chairs are going to be there. And I have some options, extra options, like, you know, I can change the orientation so they're like looking inside, or maybe I can randomize the orientation completely, or I can like combine those things. Hold on, if I do, I can actually revert this change. So if I want to randomize them, but in one axis, I can kind of combine those things. So instead of saying random, I go keep the current orientation, but I'll go also shuffle elements. And in this case, I'm gonna just have the same kind of thing because they were evenly. I mean, like, we even are sure that each of those chairs is turned the other way. I mean, like, this is quite cool side effect. Anyways, this also gives me the ability, because I'm using the the property view, single property view, to select a type of the distribution. So I can change to Fibonacci sphere, and you'll see the details panel will change because this is another object that I'm basically supplying to this widget. That now, from now on, you're not using the old distribution thing, now you're using the new one. And I'm also like moving some variables in between classes because, yeah, I don't know. I didn't know how to do it nicer in just blueprints. Maybe it's very easy, but. So let's move this up, and you can see I have a sphere now, right? So if I want, I can also do execute on copy a few times, and if I Shift E, select all, save the selection to the new one, yeah, I have more of them now. And I can do the same stuff, like, for example, go inside or outside, and this way, if you like. Have some very specific use cases in the way you want to spread things around your level, you can use this very easily and create new distributions. Just to very quickly show you how one of those look like. So I have just two functions that I override, and one of them is calculate location. The other, I can override calculate rotation and just say in which way I'm gonna modify those properties of those objects. Anyways, this is very briefly about this tool. The button, this is the same thing. Yeah, so the button that I'm using, there is a slide about it. So you just basically have to create a default editor per project user settings.ini and then add startup object. And if it was a editor utility blueprint, I guess, just an editor utility general object, you can run this. Yeah, okay, sorry. That's my mistake. Editor utility tool menu entry. Yeah, you need to create that one. And this will have this function called run. Called execute. This is where you execute your function. And run is something you used to have to add yourself, but currently there is a function in this base class that does it. And this will happen. This will happen for like when you do the startup object. So this is where you register this stuff. You can just take a look at this and yeah. And here you can see when I'm clicking this button, it registers a new menu, and that's it. Okay, let's get to the meat, in my opinion, to Python. So first of all, since I'm gonna be talking a second. Okay. First of all, Python is, you don't have to do anything to use Python in Unreal. You just open Unreal and you can start using Python. A few things. This is basically the syntax of how you would use any kind of function that is accessible to blueprints as well. You can use it in Python basically. So you do Unreal, which is Unreal's module in Python, and you give the name of your class in upper camel case, which also is called Pascal case, I guess, and then snake case, right? So lowercase with underscores for your function names or property names. And you just use variables in Python as usual. So a few things to know about setting up Python in Unreal is good to have, for example, pylint. And pylint has this kind of, before I'm going to tell you about pylint, there is this developer mode in Python settings in the editor. You can enable it in the editor settings for yourself only, or in the project settings for the whole team. Usually you just do it in the editor for yourself, because not everyone will be using Python. And this will generate a Python stub file in your intermediate files. And this, in turn, gives you the ability to get auto-completion from, for example, things like pylint, or if you are using any other IDE for Python, also you can use that. The only thing, like for example, in pylint, you will also have all those files. So maybe I'm gonna make it bigger. There is like this init hook that you need to supply, and you just give the relative path to your Python stub directory, and it will find all the stubs that are of its interest. And then in VS Code settings, for analysis extra paths and for Python autocomplete extra paths, you can add this stuff. I have like 4 times back in the front here because I'm using this in plugins. And worst case, there won't be the Python stub, and I'm not gonna have autocompletion. So then I'm just gonna enable it, and whenever I use this plugin, I can already see everything autocomplete for me. Okay, a few short things okay, this is how this will look like in Python, right? So you have your path variable, and you just do basically the same flow, the same logic. You go, does asset exist? If it does exist, branch, right? Then load asset. Same stuff, right? Very, very similar. Maybe, okay. This is does asset exist, and this is here, right? Here I just have some variables, like this path. And then load asset, it's also the same thing. The only thing that you can notice is there is some editor asset library, which is weird, and how to find out how to figure out those is basically you go and write Unreal Python API and open this link, and you look for the name of the function. At some point, you will already know what is where. So it's very actually easy to figure out. So you have this set editor property. This is one of the most useful things ever, because whenever you load an asset or whenever you have an actor in the scene, you can set any property that you can set from the editor on it. I mean, most of them at least, and you do it with set editor property. on the actor itself, right? So in this case, I'm selecting on the object itself, right? So I'm using some object and like setting sampler type to, for example, grayscale in this case. But I can also do it with Python, basically the same idea. You just what I had to do though is I had to look for types of like how those are named basically in Python. But the autocomplete also gives you that, so it's also easy. One thing that this is a little bit like this is being updated, so the editor utility library is getting deprecated in favor of level editor subsystem. So level editor subsystem will be now used instead. And how you use subsystems is you actually call a constructor kind of in this way. So you go unreal.editor level editor subsystem and then parentheses, and then you do get selection set. But this is how you used to do it, and some subsystems are still not moved over. So in some cases, it won't look the same at all. So there will be some editor utility library that you are not using in blueprints. So this way, again, go to the Python API and just go do it. Okay. So this is here. One of the cool things you can actually do with any of those, this is not necessarily Python, but like in my Megascans 3 assets. Yeah, sorry, I'm like it's. Yeah, and I'm gonna, yeah, this is the chair I'm always using for everything. So if I right click here, I have those scripted asset actions. Do you see it at all? Is it okay? I can make it larger a little. You know what? Hold on. Do you remember what was the shortcut for the widget reflector? Windows Shift something? Yeah. I learned that at my last presentation, so this shit is useful, it's really. So, yeah, well, I forgot what I was doing. Okay, right-click this. Now you should be able to see it a little bit better. Okay, I didn't right-click it properly. You know what? Funny thing, I have the other microphones here. It's gonna be way more comfortable than looking at the other screen. Okay, so I hope you see it now. And here I have create material from selected textures. If I right-click it, if I right-click the textures, and if I create the material from those, it takes a while because I need to save the asset, but you can see it generates the whole material connected. Things are connected correctly. And basically, if I select this chair in here and make it appear, what? You need to select a mesh-based. Yeah, okay, sorry. I'm not gonna show it to you now, but basically the material is very similar. The only thing that you may need to work with is like just some parameters, like multiply it by things. But this is not everything, right? You can create, of course, new materials, but what is more useful to some people is basically be able to take the same textures and instead apply them to some material instance. So I'm gonna use the default one because it just creates the default Megascans material instance using those textures. And the only thing the artist needs to do now is just, I don't know, fix the tint a little maybe because they want to have some nicer looking chairs. But this is like everything. So I'm not sure if any of you worked with creating instances from textures in the past, but it takes so long that like having this little tool that you select a few textures, right-click them, and it just fills your instance with the textures based on, actually, in this case, suffixes. I'm gonna get to those things in a second. It's super nice to have. And I can also, instead of using this default material instance, I have another option that, in this case, I can select a different material, like base material to derive this instance from. So if you have multiple of those, you can also do that. And then if you have some naming conventions in place, which you should probably, I guess, this is just my opinion. In this case, you can really easily automate things because in this case, actually, I'm using the suffixes that are typical for Megascans assets, and I just hard-coded them in the script. I can do that because I'm not delivering this to the client. I'm just doing this for myself. So I can select a different instance and have the same effect, kinda. But getting back to the one generating the materials, I guess I have those in the assets here. Not really. Okay, but what I do know what I have is, for example, like I can select different textures of different types. Let me make it bigger. You see that those have different suffixes. They're the same texture. I'm really sorry about it, but I have another example, just lost them completely in this huge project already. So I don't want to look for this on the stage here. So let's say I want to use this texture as a diffuse. Sorry, it's jumping around. It's a bit too scaled up. Diffuse and alpha, for example, right? So, and yeah, normals won't make much sense in this case. So I'm gonna just right-click it and create a new material from those textures. From this one texture, single one. I have some better examples somewhere, but you can see already that this material is translucent because I used alpha, and I can set the type of material also, why not? And then I supplied alpha from this texture because this texture had a suffix with A, and stuff like that. You can just create those things that serve your naming convention, basically. And just to take a look at how it's done. So material tool, what it does is, like, first of all, we're creating an empty material. You can just get this function. You can get this function, use it. Don't look at the code too much now, okay? We're going about ideas, not about specifics, okay? I know this is intimidating, maybe not to look at this, but yeah, this is a function that creates an empty material. I'm doing some stuff with paths. It's easy, like with Python, it's way easier than with C++, for example. We do have some stuff for paths in C++, but it's a bit easier. And in this case now, what I have is just the create material from texture, which creates an empty material and then applies texture by texture based on those selected assets that I have. And you can see that I just call this apply texture function. And apply texture function, what it does, it goes through some kind of actions set, and basically it selects an action based on the key, which is a suffix. Specifics we'll leave for later if you want to analyze it, but basically those actions are selected based on suffixes. So here I have a dictionary where if this suffix is DA, then it's gonna create a connection from RGB to materials base color. If it has it creates a connection from A of the texture node to opacity output and sets the blend mode of material to translucent. And I created those different actions so you can actually use it as a proper tool. Probably this dictionary thing could have been elsewhere, or maybe as an asset. It's also possible, but like, just modify this code, you know, go for it. And the nice part is, I mean, like, if you have already used DA, then both D and A will be removed from the suffix, so they won't be, like, the D won't be there or A when you arrive to this switch, like, you know, to this. If you are only looking for the D as diffuse, right, suffix, you will be using just this. But if you have both D and A, it will use a bit more sophisticated one. And you could create it in multiple different ways. You can also just skip this one, but I just wanted this to be different than D and A separately. You can do all of those easily. So how I created those functions, again, something Python can do very easily and nicely. Like, you have this like basic inheritance. So there is a base of action, and the action has a function called execute. I supply some generic parameters to this, and then each of the actions can have some extra stuff connected to it. So you just call execute and supply it with some and supply it with the things that you actually wanted to do. And in this case, if this is a set property, execute, it will just set a specific property based on what you supplied. The same goes for like set sampler type. It just gets the expression, which means basically expression is the node in material graph, and sets the property name of a sampler type to like grayscale, for example, for masks, or normal for normals. So you get very, very specific control over those things. And also, like, I made it so they spread out. They're not in order, but they spread themselves out, like, you know, so they don't overlap themselves, the nodes, right? Because you can set the positions of them. If you have a nice algorithm to determine like how the material graph should look like, maybe you can also create very beautiful materials with that. The same goes for material instance tool, and it's just okay. And it's just the only difference is, like in this case, I'm just setting based on the suffix of the texture. I'm moving this to be this to be supplied to the parameter of name albedo, for example, right? For diffuse. For M, it will be metalness. So in the material instance, this is how the parameter is called, and this is the suffix of the texture. So if you have, like, right at this point, you can just take this script, put here like the names of your material instance parameters, and in here also put the suffixes that you use, relate them together, run this tool on your textures. It will just work right like that, because it just like prepared in the most generic way I could. And what it does here in the bottom is just the same pragmatic, like normal stuff, just basically create a new material instance. Here actually we create a new one, and then we just go through each suffix and fulfill that. And if I don't, fulfill that and fill that up, sorry. And if I don't supply the proper base material, which is like some default for us, it will ask as well, the user. So you can go both ways. Let me take a look. Yeah. Okay. So we have slow scope tasks. Just very quickly, gonna show you what this is, but I'm not gonna show you how to do it on the slides. I'm gonna show you in a moment. So this is like this kind of window. You can open it. You can create those progress bars and use them. So now let's quickly jump back to the editor. I'm gonna use the other tools that I have. So for example, this tool clears up I can actually create a new level, to be honest. Empty level. Don't save. And you can see already here, but okay, so maybe I'm gonna go back to this project and very quickly try to create a new editor utility widget. So remember not to go down there to the the user interface. You go here. And I'm not gonna call it anything, but you can see when I right click it, I have run editor utility widget. So it opens a window, and you already have something to play with. So let me just very quickly build something, okay? So what I'm gonna add is a horizontal, actually vertical box. I'm gonna drag it in. I'm gonna make it anchored to all the walls, 0, 0, 0, 0 on each side. And then I want to have a horizontal box at the top, and then at the bottom I want to have the text multi-line box. And I'm guessing that now, if I just set this to fill, that's gonna be great, and I'm gonna add a random button. So you can see that I have this box with like where I can write text. There is some button. What we can do with that? I mean, like maybe let's on clicked, when the button is clicked, let's get the text from this multi-line text box, and let's apply it to execute Python script. Bang. And what it does, actually, this node also has inputs and outputs, by the way. So if you want, you can actually supply things directly from blueprints to Python and just give those objects there with this node. Just pass them there. But what I can do now is I can have this here, for example. And if I say, for example, import Unreal, and then say unreal.log, let's make it error. Hello world. And if I hit this button, I hope we have a hello world in the log, which means basically we created a tiny Python IDE right now. I mean, like you can now write Python directly in the editor, run it in the editor. And I mean, like you can imagine how much magic you can do with just playing with the string itself. You can do the whole pre-processing. For example, I created an asset where I had text fields, and those text fields were basically function definitions that I could use later in Python because I could inject them into this node by just using append node, right? Because I can I can have import Unreal here. I can have some script so that I don't have to write the import Unreal anymore. I mean, like a lot of things that can be done. So what I did with that is I created this tiny Python IDE, which is a little bit more sophisticated, just a little bit. And yeah, it's not that visible again. I'm sorry. Widget reflector. Let's make it slightly bigger, hopefully not too much. So let's, for example, see, in this case, I created some scripts that I can load here. And if I hit this, I already initiated like some default level, which I call like foggy pinky level, whatever. I also have a script that basically spawns a grid of actors. And in this case, I have an object here, and this is just a single property view. And the single property view has this awesome feature that if you supply it with, for example, soft pointers, it will also preload them unless you select otherwise. So in this case, if I just say 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and go down there and select a cube. I'm sorry, I mean, like, this is the way I'm selecting a pink cube in Editor now. I can hit this. There is a slow scope task which says thinking and processing like those 4,000 elements, spawning those actors, and bang, I have them spawned in some nice weird way. But we don't want to wait that long, right, before using this every time and like modifying how they are spawned. So I also created another script that instead of spawning them based on this actor, because this is, by the way, this test object, it's just this not actor, it's an asset, sorry. So this text object is an asset that I can directly access from here, because how I have it set up is I basically have an input called test object into the script in this node that I showed you, right? So I just supply this value there. And I can manipulate meshes matching this test object. So in this case, very quickly, I can redo some stuff. So for example, I can make them like spawn like at spreads from 0 to 90 degrees instead of 45. And you can see already the shape differs. One of the scripts that I was just like playing around with before the conference because I wanted to maybe do something was basically this, right? So it just takes all of them and just moves them back a little. But what is nice about it, it should actually be able to revert the changes because I'm now using transactions. So how I did it, I still have a minute. So how I did it, I created a new one, and I have snippets in here. So I can, for example, create a snippet which will say, for example, let's go with get all actors of class, and it will select all actors of class static mesh actor, right? And in this case, I'm having this A, which I'm gonna call actor instead. And it will be each of those actors that I have on the scene in here. And sorry, this is not snippets. And in the snippets, I can, for example, go move actor, right? But while, like in this case, I don't have any ID. But in Python, you can actually use I, actor, and then say enumerate. So this is how you can quickly get an ID, even if you do a for each loop. And I can just select, I don't know, paste I in here. In this case, it's not gonna be able, sorry for this new snippet. In this case, it's not gonna be able to, there's no transaction set. So what I can do here is, sorry, I have to write something because of the way it's working. So in this case, I can add a transaction snippet. And this snippet, I can now move over a little bit of this here. Hold on, I'm moving it to the beginning. And you can see that there is tiny Python IDE, do something, and transact object is a text object. We don't want that. We want each actor to be the transact object. And we want to do it before. Yeah, this is not that easy to write Python in editor, but especially, oh yeah. And now I have my, now I can transact this. I mean, like I can go undo redo, right? On this, because it basically is using the transactions now. So, you know, the idea, the general idea of this was for me to be able to quickly do and be able to like modify those things. If I want to, like, for example, make it twice as large, the difference, or like actually it's based off the current position, I can still work on that and I can still revert it if I didn't like the idea in the end. One last thing I'm gonna show you here in the editor utility widgets. It's not maybe Python, but this is just a very last thing before I show you the final slide. You can actually have a widget, have a viewport in here, and this is based off. This is how you can actually, like, in a nice, clever way, use the things that are available to you in the editor normally. So I'm using just a scene capture, which is not visible here for whatever reason, but it's probably somewhere in the fog, or maybe hidden in game. This is the scene capture, and it's here. It's just not visible at this point because I hidden it probably. But it's just a render target, you know? So you can, for example, move things even like to this level with just that much work. You can create new assets. You can modify all the assets like that you have selected, all the assets of the type. In the meantime, thank you very much. And all this stuff is under this link here, or this QR code in here. And you can download every script, every blueprint, everything I showed you. That's it, thank you. I'm not sure if we have any time for questions right now, so maybe take them out. Let's take them out for, like, you know, in front of the hall, if it's possible. So thank you.